Let's take a look at another application of using a proportion. We have the following problem. The distance between New York and Los Angeles is approximately 3,000 miles. If a commercial plane travels 100 miles in 12 minutes, how long will it take to make the trip? Okay, this is a distance problem, and we actually saw in a previous video that our distance formula is something like this. We have distance equals rate equals the rate times time, where rate also means speed. It's essentially the rate of speed or rate of change, which actually we'll go over later on. Our problem is asking us to solve for time, so let's use a little simple algebra to manipulate our distance formula so that we're actually solving for time. So let's do this. Let's divide both sides by rate. We can do this. We know that if we do something on one side, as long as we do it on the other side, we're going to be okay. We're not changing anything. So let's divide both sides by rate. Rate cancels with rate, and this is going to give us, we're going to solve for time, or t. Just imagine these as variables, and actually we'll write them as variables. Time equals distance, d, divided by rate, r. So if this was d equals rt, we just divided both sides by r. These are words, but these are also variables because they're unknown quantities. So we can actually manipulate them the same way. So this is going to be our new formula. T equals dr, and this is what we're going to use for this problem. Okay, this is actually also our ratio, so let's go ahead and plug in our unknown quantities. Let's see. We have t equals, we're looking for time. Now, we know the plane will travel 100 miles for every 12 minutes. So 100 miles per 12 minutes. So our ratio of time is 100 to 12. And this is in miles, and this is in minutes. So 100 to 12. Now, since we generally associate speed with miles per hour and not miles per minute, let's go ahead and convert minutes to hours. So miles per hour instead of miles per minute. So we'll have the following, we'll have the following proportion. We'll have 100 over 12 equals 100 over, now 12 minutes is what fraction of an hour? It's actually 1/5. 12 will go into 60. There's 60 minutes in an hour, so 12 will go into 65 times. So 12 minutes is 1/5 of an hour. So we actually have a proportion here. These two quantities are equal, and we actually know how to solve this proportion. Though this conversion results in a complex fraction over here, we'll be cross-multiplying just the same way. And the cool thing about this is our answer will already be in the proper units. So it'll be in miles per hour. So let's go ahead and set up our proportion. We have 100 miles and 1/5 hours. So these are going to be equal, but we're interested in this proportion. We're interested in 100 miles per hour. Our problem has 3,000 miles, so we're looking at a small distance of 100 miles, and we want to see, okay, well, how long does it take to cover this long distance of 3,000 miles? So we're looking for time. We're looking for how many hours. So 100 miles to 1/5 of an hour is the same as 3,000 miles to how many hours? Okay, so miles to hours. Everything's set up correctly. Since both of our ratios actually have the same units, we can drop the units until we write our answer. So we don't have to write miles, hours, and hours here, because they're all the same. So let's go ahead and solve this. And we do this by cross-multiplying. 100 times x and 1/5 times 3,000. This will give us 100 times x is 100x. And 1/5 times 3,000 is 600. Okay, this is something we can solve. We can divide both sides by 100. We want to isolate our variable. 100 cancels with 100. We can actually cancel out these zeros and these zeros. and we'll have 6 over 1, or just x equals 6. So the distance between New York and Los Angeles is approximately 3,000 miles. Given the same commercial plane, it'll only take 6 hours to arrive from New York to Los Angeles. So that is our answer. Okay, so what did we learn here? This is an application of a proportion. Basically, we used a given formula, distance equals rate times time, and the actual proportion that we used was in converting. We wanted to convert minutes to hours, and then we want to take this smaller section, this 100 miles, and we want to know if we applied the same rate of speed to the plane, how long would it take the plane to travel 3,000 miles? So we're just going from a small ratio to a larger ratio that's still equal. If we plug 6 right here, this ratio, 3,000 over 6, will be equal to the ratio 100 over 1/5. And I'll leave you that to actually prove. Just go ahead and plug in 6 for x and see that the two ratios are equal, and I'll see you soon.